So there's a lot of interest in bringing coding back, driven, by the large kind of technology industry, but also by this idea that we need to kind of understand the digital publics, the digital world we live in, because it has become so pervasive. And so people talk across about, should programming become the new literacy? And lo and behold, there's great enthusiasm. Obviously, there are also opponents to it. And I like to make that slide, programming has an R in it, so it fits, to become the fifth R because I'm good enough to include the arts, so there's 4. But when we think about programming as a literacy, I think we also need to think about what literacy actually means. And I'm very fond of taking definitions which actually a literacy scholar, Sylvia Scribner, wrote in an essay, Literacy in 3 Metaphors, and she said when we talk about literacy, we mean actually 3 things. But most often, we only talk about the first thing, which is literacy as adaption, the kind of functional part. You need to learn how to read and write, to do math, to do science, and obviously you in the Faculty of Education know big debates always nationally on what that actually should be and how we should teach it. But we're very much concerned kind of getting the basics down. But then she said, there are actually 2 other aspects on why literacy is important. And the second one she calls literacy as power, and it really kind of appeals to the civic agenda of why being literate is important. It means being literate is being able to participate in society. You have power to understand political decisions which you otherwise couldn't do. And lastly, there's an aspect which we don't hear very often, literacy as grace. And here she really talks about literacy as personal expression. When you want to write a love letter to the love of your life, you need to know how to write, but also how to express yourselves. Of course, you chuckle nowadays, you don't write a love letter anymore, you compose a 140-character tweet. But even that requires, knowing word, language, certain skills to be proficient. So I think when we talk about literacy in general, whether it's about reading, writing, whether it's about mathematics, science, history, we always should take into consideration all 3. We shouldn't just look at the functional part, which is important. And that's why I think, when we think about coding as a literacy and look at these kind of 3 dimensions, adaptation, power, grace, we can look at coding as something where we really want people to understand the basics. We don't want them to turn into computer scientists or programmers. People who want to do this professionally can do this later. But they need to have some understanding on how these systems are designed, what's hard and easy. When you press on your iPhone the button, what's kind of the mechanics on how is this coded. But we also want, on a political level, questions around privacy, copyright, how is the interface, in public institutions where a lot of jobs, everything is kind of mediated through technology. Somebody designs these things. Who has access? Who participates? So people need to be part of those discussions as well. And then finally, the personal level. And if you know anything about the youth of today, they communicate, they live through digital media, but they really don't understand very much on how the stuff they're using every day is being made and how they can contribute in a productive way. So what I'm going to do in the second part is trying to elaborate on how we can realize this vision of coding as literacy by talking about computational participation. I want to prepare you for a shift away. I think computational thinking has a great general perspective, but to me, it's focused too much on the individual, the thinker. And I think when we look at computing today, it is a really social networked activity, and we really need to think about computation also through a lens of participation. And the second point I want you to take away, that there's obviously, with this lack of diversity and equity, a lot of talk about broadening participation in computing. And I think that's good, but that's not enough, because I think we as educators also need to be concerned about deepening participation. Because I believe once we do the broadening part, we're going to be faced with the next challenge. It's not just bringing people in, it's also giving everybody enriched activities, and I'll present some examples and ways how to think about this, and where schools in particular, I think, have an important role in this. So we want to move from computational thinking to computational participation. So in order to do this, let me go back 30 years in order to make true on my claim that we actually learned a few things. And what you see here was actually part of Seymour's group. This is a picture of Project Headlight, where I conducted my dissertation studies. I asked students actually to program their own games rather than to play them. There's a book too, which by the way you should not buy, you can get for free on my website. I got the copyright back, so you can get it in any conceivable digital format. Let me show you what that looks like.
It's demo time for parents at the Hennigan School in Boston.
He will ask you a fraction problem. If you get it wrong, you will become mentally deformed.
After months of work, the 5th grade students are showing off the computer games they created. Even the principal is here to take a try. The children are using the programming language Logo, invented by this man, Seymour Papert. As part of a bold MIT Media Lab experiment known as Project Headlight, Papert, his research team, and the Hennigan teachers are developing methods to put inner-city children in charge of their own learning. Instead of using purchased software like most schools, Project Headlight challenges the students to use Logo to create their own software.
How do you decide what to put in your messages when you get it right? Well, I am basically on the same. I don't know. I just got it. And the encouragement of it was right.
What do you say when they're wrong?
That's wrong. Trying to think again.
In the design process, they become expert programmers. They draw, manipulate shapes, even guide a skier down the slope. And like all the students, this one is built in a surprise. When the skier hits a bald spot, a fraction quiz. No run-of-the-mill video games, these are designed to teach mathematics. Abigail has chosen to design her fraction game around the Greek myths.
You want to go to the home of Zeus, but the map was ripped up by the Greek god Hades. All the Greek gods and goddesses have a fraction of the map. You're to go to the gods and goddesses one at a time.
Her toughest challenge involves allowing the user to choose an answer from the quiz. She's had to learn the hows and whys of the ifs and thens.
The hardest thing about this is making the program for what's your answer is fraction problem. And if you push A, then you do this, and then if you push B, then this happens, and C, then this other thing happens. So it's really hard.
The fact that a 9-year-old is learning such sophisticated programming concepts is a testament to Project Headlight's success. And for Abigail, the command of the computer allows her to devote her attention to what she really enjoys. Designing a Nintendo-style interface and creating a compelling story around the gods. Ginny has designed her fraction game around the spider web. Like her classmates, she's learned advanced programming. She's also learned the advantage of producing her own game.
Because you make your own game and you can play it anytime you want, but in Nintendo, this right here, you don't have to buy it because you're the one who's making it.
With Nintendo as a model, she's even designed her own game box.
Like at first I didn't know how to design a web, and so the art teacher helped me and I designed it.
In fact, as part of the project, all of the children package their games and promote them with an ad campaign. These integral activities make this project unlike any textbook exercise. The students here are designing a real product from start to finish. And through the process, they learn about every advertising medium. They even produce TV commercials.
If you play this game, play good, you may grow up to be like Ronald Reagan. Wow. Pushing Town is awesome. It's spooky, it's scary, and it's exciting. And it's by GCA. Awesome.
So you get the idea. This was a long time ago. These were 256K machines. I mean, the smartphones you have today on your pocket are orders of magnitude more powerful. But you could see what the students created. And I think there are a few things which looked very differently from also how many students at that time, more than 25 years ago, learned programming. For one, they actually created a product. So rather than just to write or learn code for the sake of coding, they learned it in order to create instructional software to teach younger students in their school about fractions, the very same topic they were learning actually in their math class. It was also integrated, not just with the math class. I mean, you saw a lot of writing going on. Obviously, the Greek myths were part of language arts. There was a propaganda unit, and the final project was that all the students wrote the propaganda. There was the art unit involved. I mean, you saw the packaging. This, of course, nowadays nobody buys software in a box, but 20 years ago, you actually had very intricate boxes. You went into a store and bought those. So the idea was also for students to spend an extended period of time. Most students not just spend 1 hour, but maybe just a few hours of learning programming, and that was it. And why would we expect any change from just such few hours? Here, students actually had spent 4 hours per week, at least 10 weeks, to kind of design the software. So the lack of time, the lack of integration with the curriculum, as well as finding a way for students of personal expression really made that project very different. And I think they also resonate very well with Seymour's principles, which he expressed in Mindstorms, and in the theory, which at the time actually wasn't coined yet, Constructionism, and the idea that you kind of use the creation of artifacts, whether it's a computer game on the screen or a robot or anything you build, very much in line with today's maker movement of making things, is, and then you share it with others, is really a driving force with learning. And at the time, you have to remember, many of those ideas were not yet very popular in educational theory, but this idea of objects to think with, using objects, is actually something which is at the heart of the theory today. Equally important is the social aspect. Seymour in particular was very enamored of the samba schools in Brazil because they were intergenerational. People learned from each other, and they also prepared for a performance, so there was a goal for what you all learned. And so he thought learning wasn't necessarily just an individual activity, but there was also needed to be a social context and a performance. And nowadays, many theories of learning actually argue for communities of learners or practitioners and see the importance of not just having authentic and relevant context for connecting your knowledge, but also engaging in social interactions in form of collaboration or other ways. And then there's also the notion that the culture in which learning takes place and what he called epistemological pluralism is equally important. And it's obvious, in particular in digital technology, digital computer culture, We have very many preconceived notions. Who should participate? How should people go about problem? Is it top-down or is it kind of more tinkering? What is being made? Should it all be robotics or can we do also other things? So it's not just the individual learner, it is also the community and the culture which we create, which are really critical for thinking about how to do computational participation. And I like to kind of take Seymour's notion of the objects, whether they're built on the screen or in the real world or some hybrids, are not just objects to think with, they're also objects to share with. I think this aspect was always there in his theory, but in today's connected world, it kind of comes more to the fore.